good afternoon. I'm here to videotape a series of video clips for you to learn EChem. To start off with, actually we should do a revision on AC theory that you learned in your year 1. Okay? Now AC theory in your year 1, the single phase, we started off by saying that AC signal, right, can be represented in 3 forms. I can give it to you in a diagram form. In other words, I draw a sine wave, voltage, time, and I say that this is 14 volt, here is minus 14 volt, and the period is 0.02 second. Okay, so I know that this sine wave has a peak value of 14 volt, peak to peak is 28 volt, and the period is 0.02 second. Or I can give you a sine wave in a sinusoidal expression. Sinusoidal expression is the mathematical expression. So if I will say that Vt is equal to 16 sine 314t volts. So this is a sinusoidal expression. And you should be able to interpret from this sinusoidal expression the different parameters of the sine wave. The third one is actually a phasor form. Phasor is actually a complex number format. So if I say that this AC voltage is equal to 25 0 degree volts, 50 hertz, and from here you actually know that this is actually a sine wave. Alright? So a sine wave, an AC source can be represented in 3 formats: a diagram form, sinusoidal expression, as well as the phasor form. So let us now go into this one in detail. Okay? If it is a sine wave form, are you able to tell that the peak voltage is 14 volt, peak to peak is 28 volt, this is double, and the period, the VRMS is equal to Vp divided by square root 2 volts, so it's therefore equal to 14 divided by square root 2, and if I were to use my calculator, it gives me 9.89 volt, so that's the VRMS. Right? Next, from the sine wave here, the period is the time for one complete sine wave. So period is equal to 0.02 second. Okay? And frequency is 1 over t, reciprocal of period. So it's equal to 1 over 0.02 hertz. The unit for frequency is hertz. Okay? These are called the parameters of a sine wave. Peak voltage, peak to peak voltage, RMS, root mean square voltage, period, and frequency. Alright? Now, when you use your multimeters and you switch to an AC mode to measure the AC signal, the value is actually the RMS. Okay? So that is called the diagram form. Now, the second way of representing the sine wave, as I said just now, is actually a sinusoidal expression. So if I give it to you, a sinusoidal expression of this 16 sine 314t volts, it is actually Vp sine 2 pi ft volts. So from this mathematical expression, we know that this sine wave has a peak value of 16 volt. Alright? And peak to peak is double, so it's 32 volts. And VRMS formula is Vp divided by square root 2, so it's therefore 16 divided by square root 2, and if we were to use our calculator, that is 11.3 volts, 31 volt. Right? Now after I get these parameters, then I look into what else can I get. Now from here, 2 pi f is equal to 314. 2 pi f is equal to 314. So 2 pi f is equal to 314. So f is equal to 314 divided by 2 pi, and you find that the answer is about 50 hertz. So with that, I get my frequency first. And therefore, period is the reciprocal of frequency, so it's 1 over 50, and that's equal to 0.02 second. So when you are given a sine AC source or AC signal, in the mathematical expression, we call it the sinusoidal expression, you are able to give me the parameters as well. The peak voltage, peak to peak voltage, VRMS, frequency, and period. Right? So with that, now let's move on to the third one, which is the phasor form. So if I were to give you a phasor form, in other words, the voltage, and I say this is equal to 25, 0 degree volts, 50 hertz. So I'm saying that this sine wave has a frequency of 50 hertz and has this, what is this two value? This is actually VRMS and this is actually phase angle. So in other words, from here straight away, I know that the VRMS is equal to 25 volts, right? And therefore, what is VP? If you remember that VP is equal to what? You remember the formula, VRMS is equal to VP divided by square root 2, right? So now, if I know VRMS, can I find VP? Yes. VP is equal to VRMS multiply square root 2. So that is equal to 25 multiply square root 2 volts. Okay? And that, if I were to use my calculator, that is 35.35 volts. If I know my peak voltage, am I able to tell me the peak to peak? Double of it. So it's 2 times the peak voltage. So that's equal to 70.7 volts. Right? And from here, I'm given the frequency. This is the frequency. So frequency is equal to 50 hertz. And period is equal to 1 over frequency. So it's 1 over 50. So that's equal to 0.02 second. Okay? So what we have just gone through is the AC signal. An AC signal can be represented in 3 ways. 1, if I give it to you a sine wave. 2, I give you a mathematical expression of the sinusoidal expression. 3rd, I give you the phasor form. Okay? So let us practice some examples of this. Alright, let's practice. If I were to give you a sine wave, and I say that this is equal to 17 volts, minus 17 volts, and here is equal to 6, here is equal to 12, here is 18, and time is millisecond, and this is voltage. The peak voltage is 17 volts. The VRMS, 17 divided by square root 2 volts. The peak to peak, 17 multiplied by 2, 34 volts. Period is equal to 12 millisecond. It's not 6 but 12 because it's the time for one complete sine wave. And frequency is 1 over t, so it's 1 over 12 times 10 power minus 3 hertz. So that is called sinusoidal. Give it to you. You get the parameters from a sine wave. Now, if I were to ask you, convert this into the sinusoidal expression for me. Make this into this for me. And you know that the formula is Vp sine 2 pi ft, right? So therefore, what is the peak value? It's 17 sine 2 pi, what's my f? My f is 1 over 12 times 10 minus 3, right? So I do the same. So that is the sinusoidal expression. When you are asked to give an expression, the t is a variable, you leave it there. Got it? Okay, so I'm able to convert a sine wave into a sinusoidal expression. Next, the same sinusoidal expression, I ask you to make it into a phasor form for me. Alright, I want it to be in phasor form. So what is a phasor form? It's VRMS and then theta. Am I right? So what's the VRMS value of this sine wave? 17 divided by square root 2. And what's the angle? Because it starts with 0 degrees, so it's therefore 0 degree volts. Okay? So that's called sinusoidal expression. Alright, second point about our AC theory now is about the complex number. Do you still remember your complex number? Okay, you must, for this module, a lot of the mathematics are actually based on complex number. So you must know how to use your calculator to do complex number mathematics. If you have forgotten about it, go Google and find out the the manual and then find out how to convert rectangular number to polar number and polar number to rectangular number. Okay, let's try. 3 plus J4, if you were to use your calculator, this is called rectangular form, can be made into a polar form, and that will be 553.13 degree. I know this because I know my numbers, okay? You can use your calculator and try. Likewise, 3 plus J4 is equal to 553.13. 53.13, if I were to use my calculator to convert to rectangular number, it will give me 3 plus J4. Okay, I'll advise you to remember this set of number 3, 4, 5 and 53.13. Because if you know this number by heart, when you use a calculator to get answers, if you are not too sure of your step, at least you can verify by using this number. If you input in 3 plus J4 and you cannot get 553.13, that means something is wrong with your calculator stats. Okay, if you know this conversion, you are able to convert rectangular to polar, polar to rectangular. Alright, so now let's talk about mathematics. Okay, if I were to add number 3 plus J4 plus 553.13, you must convert this into rectangular number. So this becomes 3 plus J4, right? So this is actually 3 plus J4. So when you add these two numbers, it becomes 6 plus J8. 6 plus J8. Okay? So that's addition. Subtraction. If I have 8 plus J10 minus 553.13, subtraction. Likewise, you must convert this into 3 plus J4. Right? So 8 plus J10 minus 3 plus J4. 8 minus 3 is 5. 10 minus 4 is 6. So that's called subtraction. So in mathematics, complex number, when you want to add, both must be in rectangular form. When you want to subtract, both must also be in rectangular form. Multiplication. If I have two numbers that I need to multiply, I must make them both in polar form. So that is 553.13 degree multiply 553.13 degree. 5 multiply 5 becomes 25. The angle you add, multiplication you add. So 53.13 plus 53.13 is 106.26 degree. Right? So for multiplication, you have both must be in polar form. Right? Division. If I have division 553.13 degree, rather, I have 20 degree divided by 3 plus J4. Right? Division. Then both must be in polar form. So I have to convert 3 plus J4 into polar, so that's 553.13 degree. Okay? So 24 divided by 5, that's the number. When angle is concerned, you subtract. Division you subtract. So 20 minus 53.13 is minus 33.13 degree. Okay? So that is called complex number. Complex number. Alright, if you do understand what I've just said, let's summarize it. When you do addition and subtraction, the number must be in rectangular form. When you do multiplication and division, both numbers must be in polar forms. Right? When you multiply the angle you add, when you divide the angle you subtract. So that's called rectangular form, complex number. Alright, just to have a quick exercise, you don't need your calculator. If you understand what I say, the numbers should come out very quickly from you. Let's try. 3 plus J4 minus 553.13. What do you think is the answer? You have to make this into 3 plus J4. So 3 plus J4 minus 3 plus J4 The answer is 0. Correct? Okay, let's do an addition. 3 plus J4 plus 5, 53.13. The answer is, you make this into 3 plus J4. So 3 plus 3 is 6. J4 plus J4 is J8. Right? Division. Or multiplication rather. 5 53.13 degree multiply 3 plus J4. What must you do? Convert this into 5 53.13. So 5 times 5, 25. Angle 53.13 and 53.13 is 106.26 degree. Right? So that's multiplication. How about division? You must make this into 553.13 as well. So 5 divided by 5 equal to 1. How about the angle? 53.13 degree minus 53.13 degree become 0 degree. Okay? So make sure that you know how to do your mathematics of this complex number. Addition, subtraction, both in rectangular form. Multiplication and division, both in polar form. Now, why do we need to learn this? Because subsequently in EChem, right, a lot of times you need to do mathematics like this. Can you remember your Kirchhoff's current law? If I were to say that total current is equal to I1 plus I2 plus I3. Right, now when you are doing this mathematics, all of them must be in what form? Rectangular form, that's correct. Then when you want to find this Z is equal to V over I, Ohm's law, remember impedance, voltage divided by current, both must be in polar form. When the two impedance, total impedance, they are parallel, and then I want to use this mathematics. Can you recall your parallel impedance? Right? So this is division. So both must be in polar form, polar form, polar form. When you add them, all in rectangular form. Then when you do inverse, which is actually a division, so polar form again. So you must convert polar, rectangular, rectangular, polar in a very confident manner. Right? How about when I want to find the total impedance of two impedance in parallel? The shortcut is this Z1 times Z2 over Z1 plus Z2. Right? Now, if you want to do this, these two in polar form, rectangular form, when you do the overall, polar form again. Get it? So that is the usefulness of the complex number. You must know how to use your complex number effectively. Alright, let's try another example. If I have an AC circuit, I have three impedance. Right? Impedance 1, impedance 2, impedance 3. Then to find the total impedance, I say is impedance 1 plus impedance 2 parallel with impedance 3. Correct? Yes. Then I say impedance 1 plus 1 over impedance 2 plus 1 over impedance 3 inverse. Polar form, rectangular form, polar form again, and then rectangular form again to add with another rectangular form to get my final answer. Right? So if you do not know your complex numbers mathematics, then you cannot get the answer out in a very effective manner. Right? So that is the complex number. Alright, the third point that I want to go through with you now is Pythagoras theorem. Now, a lot of times in this subject, you are going to talk about impedance triangle, power triangle, and they are all right angle triangle. So you must have the good graphs of Pythagoras theorem. Okay? Now, so if I have R x and this is z. So we see z is equal to r plus jx, right? So if this is 3 ohm, here is equal to 4 ohm, then what is this? Alright, then you say this is equal to 3 plus j4, 3 plus j4, because it's pointing up. So Pythagoras theorem, or using your calculator, it will give you 553.13 degree ohms. Okay? Now then the next thing that you ask, can I find out this angle? Of course you can. Cosine theta is equal to adjacent divided by hypotenuse, 3 over 5. So it's equal to 0.6. Therefore, you inverse your theta, cosine theta, so that gives you 53.13 degree. Yeah? So that is called Pythagoras theorem. Okay? 3 square plus 4 square is equal to 5 square. Yeah? In other words, z is equal to square root of 3 square plus 4 square, and that's equal to square root of 25, so that's equal to 5. In other words, in a right angle triangle, 3 square plus 4 square is equal to z square, and z can therefore be found, and angle can also be found. Okay? Another thing about right angle triangle is the trigonometry. Right? Trigonometry. Now you have learned in your engineering mechanics that you can, if I were to call this P and Q and this is S and this is theta, you learn that P square plus Q square is equal to S square. That's Pythagoras theorem. Pythagoras theorem. You also learn that cosine theta is equal to P over S. Right? So in other words, P is equal to S cosine theta. P is equal to S cosine theta. And sine theta is equal to Q over S, opposite divided by hypotenuse. So therefore, Q is equal to S sine theta. Right? So in a right angle triangle, if you know any of the two things, you can find out everything. Okay? I repeat, P square plus Q square is equal to S square. Cosine theta is equal to P over S. Sine theta is equal to Q over S. And if you know any of the two, you can find the rest. Alright, let me illustrate with an example. Okay, so I have a right angle triangle, and I say that this is equal to 3 and this is equal to 4. Then I ask you, hey, what is this? What is this? You can use Pythagoras theorem. S is equal to 3 square plus 4 square is square root of 25, so that's 5. Right, so you know now S is equal to 5. Right, then say, hey, find me the theta. Then say, okay, cosine theta equal to 3 over 5. 3 over 5. So that's equal to 0.6. Therefore, theta is cosine inverse 0.6. So that's equal to 53.13. Got it? Okay. How about another example? If I were to give you a right angle triangle, right, and I say this is theta and this is equal to 3, then I ask you to find this. And I give you the information that cosine theta is equal to 0.6. 0.6. Okay? Then you say, okay, how do I find these two things? Okay, let me call this x and z. Alright? That's okay. Cosine theta is equal to 3 divided by z. Right? 3 divided by z. I know cosine theta. Can I find z? Of course. Z is equal to 3 over 0.6. So you get the answer. Right? Then how do I find x? X, if you were to use Pythagoras theorem, z square is equal to 3 square plus x square. You know z, can you find x? Yes. X is equal to z square minus 3 square and then square root. Okay, so the point that I want to tell you is that give to you a right angle triangle, give you two pieces of information, you can find out the rest of the information of the sides as well as the angle. Okay? Alright, so that completes our part 1 of our revision of AC theory.